So starting the subject of managed switches. So a normal switch is a very good thing because we don't have to set anything up on it. So these are managed switches. We don't have to configure anything. We just have to have a switch for each of our networks. Have to keep them separated. A lot of people for a lot longer than our shows have been using managed switches. So why did we not do it? Well, we resisted for a while because every time you add something that needs more configuration from a network point of view, the more everyone has to know about it to use it. So the people setting it up have to need to know a lot more to set it up. But more, the people who have to use it every day, it's fine when it sits in a rack doing its job, but the second it has a problem, they're harder to fix, they're harder to swap. So we resisted for a very long time. But nowadays we are using them. So what do they bring to the party? Why are we suddenly going, oh, we should be doing this? And hopefully through talking through some of the ideas over the next few things, these points will make sense. They give us flexibility because they're very configurable. We'll explain what that means a bit later. They help us reduce the amount of cabling we need between locations. So between, say, our mix position to backstage, to our amp rooms, to our radio room, it reduces the amount of cable we have to run between the two, our network cables. They give us some control over network bandwidth, which with more and more devices nowadays all using and sending data, we actually have to worry about bandwidth. On certain parts of our networks nowadays, we are very tight on bandwidth. 1 gigabit per second links are now not enough between certain locations. And the last part is they give certain types of data priority, which is particularly important to us when it comes to digital audio. So Dante, Milan, AVB, most of us understand that with digital audio, we have to have a very accurate clock, the sampling clock that says 48K, so 48,000 times a second. Be very precise, you need to sample the data in every audio input, and then that data has to come across the network. In first bits of digital equipment, most of us will have heard of word clock, and you would distribute word clock, which is on a BNC mostly, to devices to make sure they're all at exactly the same time. Nowadays with Dante networks, Milan networks, AVB networks, we don't have to run this external clock signal. It's another message on the network, this timing clock, this pulse that says sample now, sample now, sample now. But that is very, very time critical, that message. So if we put everything on one network for 1 second, so we had, in our production tables, we had our digital audio network with Dante, we had our radio traffic, we had Gareth's internet, all running on the one network. Gareth suddenly downloading something from Dropbox. A network switch would prioritize that data where it doesn't know to prioritize on an unmanaged switch. So that data might get priority over the clock signal. Not ideal. So with managed switches, you can actually tell it that certain types of messages get absolute priority. So the second that that message arrives on any port, it stops transmitting anything else and just sends that message through. So we can set priorities for different types of messages. And that's very important when you have a large-scale Dante network. And AVB, you have to have a particular type of mode of switch nowadays to be able to do that. You can't do it as easily as you can with Dante. I think it's the same with Milan, but I'll stand corrected. So one of the points, so making it simpler. So this is a drawing showing the very basics of 3 networks that we would used to do, sort of do. And we have our control network, which is in blue. So that's things like our amplifiers, VNC control, that should be on the radio world. And then in orange, we have all our radio data. So this is all our radio receivers spitting out the fact they've got good reception at this amount of RF strength with this audio level, all that data. And then in red is our digital comm. So HelixNet here, all talking away. So we talked about last week the idea of trying to keep these things segmented, and there's good reasons for that, based on broadcast messages and various other things. If we wanted to keep to that philosophy without using managed switches, for every network that we want to do, we'd have to put more and more network switches in every location. So in this simple drawing, we can see that front of house, we've got 2 networks, which is one for comm network, one for show network. In our radio room, we've got one for show network, one for radio network. Amp room has got comm and control network. And then between each location, we have to run a cable for each network. Now this is not very flexible. If in the middle of production, we suddenly need to add some comm somewhere that we haven't put some comm network cables in already, now we've got to run extra cable out to that location. If we need to monitor radio receivers from a different place, we need to put another computer in with WaveTool somewhere. Now we've got to run cable from the last place that we have a switch that's handling the radio network. So it's very fragmented and not very flexible. It's all rigidly designed from the beginning, and anything we want to change through the production process, we would have to physically run a lot of cable. We can't instantaneously grab a network somewhere. So managed switches offer us a way to make this a lot better. And it's through the thing called VLANs, which used to be a bit of a voodoo word. And I think nowadays it's become so common that it's almost second nature for a lot of people. And again, you don't have to understand a lot of the detail, but some of the core concepts are very important. So just looking at one of the recent shows I did, I ended up with 4, 5, 6, 7, 8, 9 networks that we were running on the show. Now, hopefully all of those, I wasn't running tracker network, I did that one for fun. But these are all the different networks that we're typically running on our shows now. So we have control network, all the amps talking, VNC, radio network we talked about, comm we talked about, tracker networks, and now on the tracker shows, all the tracker sensors live on this network and talk back to their computer that makes all the decisions. Seemingly, unfortunately, more often than not, we're now having to KVM extend remote stations when we don't have mixed positions in ideal places. So we have using XDIPs, which use network to do KVM. They use a lot of bandwidth, so we give a network to that. If we're mounting keyboard computers in our racks, I try to do a keyboard network nowadays, so we can drop a network at their production table without them having to get into the racks to get to do their file sharing and stuff. And then, of course, we're running Dante. And quite typically, I've been doing it as 3 networks. So our main audio in the auditorium is 2 Dante networks, primary and secondary. And then I've done a 3rd Dante network, which is for radio monitoring, for WaveTool. Most people familiar with all of those sort of ideas? So if we go back to this drawing here, this only looked at a tiny, we don't do shows with only 2 amplifiers, and they're not all in the same location. We don't do shows with only 4 comms panels. We don't do shows with only 3 radio receivers. And this is only looking at a very tiny bit of 3 networks. Well, suddenly we've got 9 networks worth of equipment. And if we had to do individual switches for each of those networks in all the locations they were needed and run the links between them, it would get crazy. So what does VLANs enable us to do? So they take, in the very simplest terms, it enables a big switch to split itself into lots of smaller switches that are completely isolated. So in this drawing here, I've chosen 4 ports to be on the green network, 4 on the red, 8 on the yellow, 8 on the blue. Now that is dividing this big switch into 4 switches. So that is the equivalent of 4 of those switches now in a box. How I divide those up, how many ports I put on each network, I choose. That's a choice. So now this is getting into the world where we get to make choices. So in a location, if we want a lot of control network ports, but only a couple of comm ports, I can configure most of the ports on the switch on the control network and a few of the ports on the switch on the comm network. I can choose per location which ports are on which network. But what it does is only the ports in red can talk to each other. They are like the equivalent of an isolated network. Yeah, the concept's okay? Great. So now if we look at our previous example, but with this idea of splitting switches. So before, we had multiple switches in each location. And that's with only 4 networks involved at this point. We would have a lot more. So in very simple terms, this is now how it would look if we use VLANs, but not using VLANs fully yet. This is part 1. So I divide my switch into these 4 parts and put one in each location with that split. And providing I plug devices into the right ports, I can configure the networks as they were before. So I want all the devices on the blue network to be able to talk together. As long as I plug them all into ports that are in the set to be the blue network, they'll communicate. Yes, it's just like, so top left, at front of the house, it's like having 4 individual switches, a blue switch, a yellow switch, green switch, and a red switch, but they're all in one box. But I've still run a cable for each network between locations. Just to show you, so we've gone from that, where we had to use different switches for each network, but I cable for each network between locations. And all we've done in step 1 is say, well, actually, that's very wasteful having lots of big switches and only using a couple of ports on each. Let's split the switch in pieces. But I'm still running the red network, a cable for red network between front of house and the amp room. So the comm can be a cable for radio network and a cable for show network, just to show step 1. So all we've done at the moment is split our switches in pieces inside. That. So it's become 4 switches in a box. That's the first step.
Hey, Russell.
Yes, sir.
Would you also marry a specific unit to a port, or just within your boxes, are the ports just all input or output?
As far as the switch is concerned, they are just ports on a network that you choose. Because of the very fact that you now have to pay attention to which device is going to which ports, I do stipulate which device connects to which port, just for ease of fault finding.
Yeah, over in the UK, we tend to put a little infographic on the side of the switch, so you just have you print it out and you can just read what's going where. And
but as far as the switch is concerned, at this level that we've talked about, all 8 of those blue sockets are identical. I think that was your question, yeah?
Yeah, very good.
So as far as the switch is concerned, they're all identical, as long as you plug them as you've configured them. But as Dom rightly said, there's no indication on the outside of these switches that they're different networks. So it's imperative that we put, what did you call it, infographics?
Sure.
Yeah. It's imperative that we do a little picture, but we'll come to that in a minute, or we could just get big red and green and yellow and blue stickers out. I mean, either way works.
Do the Luminex ones not have lights that change colour, or am I completely imagining that?
You're imagining that.
Okay.
They have lights that change colour like any switch to indicate speed and bandwidth.
They do.
And there's one light for lags.
Right. Okay.
They've released an updated model, Russ, that does VLAN identification color on the units now.
Dan corrected them.
They're great.
In fairness, yeah. Okay, cool. Thanks.
And the other place you would have come across coloured light indicate something on network ports is on a DS10.
Got you.
So
Yeah.
those sockets, the LED above each socket can be green, yellow, orange, or blue, and they depend whether they're in set to be in primary or secondary, or
Got you.
but then not entirely related to VLAN.
Have we not decided to move away from the Luminex switches now, because the number of ports and such, we're going kind of just started using mostly on stuff, I think.
I think it's kind of a show-by-show basis. Certainly, you, Andy, I think all of us, Matt, and Josh, and everyone have done shows on Cisco's quite merrily without the Luminex. Now, Luminex have brought out quite a good few new products. There's now high-density port ones. Starts to make them more interesting again, because 12 ports was ridiculously too few. The second part of them is they have very smartly jumped on the AVB compliance. So unlike Dante, which will work on even on unmanaged switches, AVB absolutely has to be on a managed switch, and not only be on a managed switch, but it has to be on a switch that has an AVB mode. And it's to do with clock timings. And Luminex have a one-tick box that do that. Most other switches, it's a license, and only certain makes of other switches can even do AVB. But it's most of those, it's a license. There's a couple of Cisco ones where you buy the license. Luminex, I believe, it's a firmware upgrade for some of the older modules, and it's built. Once you bought the switch, they do it. So they start to look attractive again if you're doing AVB switching, because price-wise, you don't have to buy a license. So
do Luminex support fiber?
Yeah, they do some models.
yeah.
I think the biggest limitation with the Luminexes, as opposed to what the schematics here are showing, is that, I mean, assuming that yellow and blue is, for example, a primary and a secondary Dante network, I also see that one thing that the Luminex VLANs do not allow you to do is set different IP addresses for it. So the switch has a global IP address, and all the groups, or the VLANs, like they call them groups, they would need to be set to the same IP address. So you cannot run and the primary and the secondary Dante network. So that is a big disadvantage.
Which Ordinate would argue is a good thing, but yes.
I think the other thing that's worth remembering about Luminex is that the Luminex switches are now officially supported by Avid as a way of distributing AVB, the actual main backbone of the console. And also, they are still the only network switch that D&B will officially say you're allowed to use for DS100. Now, which is why we forced the specs to be Luminex for the early few DS100 shows. Now we've got more confident with using SG350s and 300s and that kind of thing, and D&B have now basically said, okay, we're happy for you guys to use Cisco switches, but officially DS100 is still only supported with Luminex officially, but they're happy for us to use it. They use other things now.
I think, truthfully, Dom, if the budgets are there, and why not? Let's do Luminex. But on a show, unless we need to, I think I certainly feel our general thinking is unless we need to because of AVB, we have no reason to force it.
And certainly there's been a couple of shows we've done recently where we've had them on the shelf. Andy, what was the reason we ended up doing it on Back to the Future? We did use Luminex switches, didn't we?
Yeah, we used them because we spec'd them and they had them, so we used them.
I think the only thing is on the 12 core ones that everyone seems to have is they don't support fiber. Which
that's the big reason not to use them. Why we haven't used them on some shows is for the fiber.
Using MTP and stuff, which we are now, which is proving really good. I think that's why for me.
It's also necessary from a bandwidth point of view now, to be honest with you, on the trunk routes. I think it's just horses for courses, Dom. It's what's appropriate is the answer. Cool. So that's just go back to this picture. That's one step. So now we've reduced the number of network switches, but it's still pretty messy and that. Now, Luminex does actually enable you to give colors to each VLAN, or groups as they call it, as Chris rightly says. But unfortunately, like most computer equipment, it's all numbers. So actually, VLANs, you have to give them a number. And that's called the VLAN ID. So this is our list of networks again. And we've seen that with VLANs, step one, we can reduce the number of switches, which is helpful. And we can reconfigure the ports to be part of any different network. So if we suddenly go, oh, actually, we need another show control port here, and this port I set up to be a COM port I don't need anymore, you can change it. But in the example we just looked at, as I said, there's still a lot of interconnect, because in this example, we're still doing a single cable between each location, or fiber. So then we move on to part two of VLANing and managed switches, and that's the concept of trunks. So between locations, instead of running a cable for each network, I can run one cable or one fiber, one pair of fibers, to link between the switches. And what this does is down a trunk link, all of the networks, all of the different VLAN networks, all travel down this cable if they need to. And the switches at either end mark the data in a way that they identify from which network they were from. What that means is, you can think, if we stick with our colors for a second, once we connect all our switches together with these trunk links, all blue ports anywhere on the network, anywhere in the building, act as one network. All red ports anywhere in the building will act as one network. So we only have to run one link, and down this trunk link, the data is marked as I'm from the red network, I'm from the yellow network, I'm from the green network. And then the switch at the other end only sends it to the right colored networks. Yeah, that principle, okay? So as I sort of said, sadly, we don't get to choose colors. Underneath the hood, the switches think of each VLAN as a number. And that's a number between 1 and 4095. Then on each switch, each port, so by port I'm talking about the physical sockets, each socket on each switch, we have to decide which mode it's in. And there's fundamentally two modes. Again, I'm broad stroking here, so some people pull me up. There's two modes fundamentally, there's access mode and trunk mode. If I tell a switch that socket 1 is in access mode, it can only belong to one network. So I would have to say, on this port, access port, this port 1 on my switch, I want that to be the red network. Then I'd set port 2 to be the red network. But then I can say, well, actually, port 24, I want to be a trunk port. And what that means, it will get all the networks. So back to this drawing, all the individual sockets with the colors are access ports. They only can talk to one network. But these couple of sockets at the end, I've put into trunk mode, which means they will carry all of the networks between the switches. So we have to tell the switch for each socket if it's a trunk or if it's an access mode. And if we choose access mode, we have to tell it which VLAN we want that port to use. Yeah? So each VLAN has a number. So what's actually happening inside the switch? How does these different messages get through a trunk and come out correctly at the other end? And there's this thing called tagging, and that each message, each piece of data, each packet gets tagged with its VLAN number. So how does this happen? So outside the switch, we've got a very simple switch here, and we've set up 6 ports on this switch to be access mode. But we've set ports A, B, and C to be on the blue network. And we've set ports D, E, and F to be the yellow network. And then we've set up one trunk port, which I've tried to do a multicolor because it will be able to carry both networks between devices. So we connect a computer to port A. It's got some data that it wants to send. As it goes into the switch, it gets what's called tagged. So it gets marked saying this piece of data is from the blue network. So now internally in the switch, that data is associated with the blue network because it came in through a blue network port. So now what the switch does, so bearing in mind the rules of a switch, the way a switch routes messages, sends messages out, is it learns which MAC addresses are on the ends of which sockets. However, with VLANing, it sets itself a different restriction. It will look for the destination MAC address of that message only on network ports that are blue. So, in this example, the message arriving on A, the switch will only allow it to go out of the switch on ports B, C, or the trunk port. The switch will never, ever, ever allow it out of ports D, E, or F, even if the computer it's actually destined for is on port D, and we've made a mistake how we've set the network up. The switch will never, ever let it out of that port. That's the complete isolation. So if we look at this in slightly more detail, same switch, we've got a few more devices set up, and we're doing a kind of control network on blue and a radio network on orange. Very simplified example. So we have our system computer, and its MAC address is underneath its name, and we're running R1, and it wants to send some data to the D20, which has that MAC address, 98. So it will arrive on blue port B, but at this point the switch doesn't, from the computer doesn't care what VLAN is. That piece of data goes into the switch, and it gets tagged. And it gets tagged that it came from a blue network, or it would be a VLAN number. So it's come from network VLAN 1. Now its destination is 98A2. The switch has learned where all the MAC addresses are, but it will only send it out of a blue port. Now, fortunately, in this example, its destination is the D20, and that's also connected to a blue port. So the message will come out, and it's all work. Everything works. We've set our network up correctly. Now, in a slightly different, more normal example, we'll have some computers in front of the house with one switch. Then we'll connect a trunk port down to the stage, and slightly simplified, so the stage end, we've got one amplifier and a couple of radio receivers. Now, same thing happens again. R1 sends some data, comes in through a blue port, so it gets tagged that it's come from a blue network. Now, this switch has learned that 98A2, the destination MAC address, exists on the other switch. So it knows to send it down the trunk cable, because any network can use the trunk cable. And then it will come out of port P. So in this particular scenario, data to and from system computer 1 can only ever come out of ports A, B, P, Q, or R. If the destination that we require is not on those sockets, it will not come out. Yeah? Everyone all right? I know we're getting near the end, so it's getting harder. So, as I said, unfortunately, unlike only the Luminexes can we use color, but this is VLAN numbers that I typically have been choosing in recent times on our shows. So I set our control network up as VLAN 1, tracker network as VLAN 2. That list you can read for yourself. I'm going to try and wrap it up so people can ask questions in a minute. I'll send the PowerPoint afterwards. So actually what we're now doing on our shows is we put, slightly simplified, we put one of these managed network switches in each location, one at front of house, one in the radio rack, one in the patch room, one in the band pit racks, one in the amp room. And we connect them together with one cable or one pair of fibers and set that fiber to trunking. What that means, once that's our design of our network, what that means is we can then decide on any switch, any socket to be on any network. And that's where the flexibility comes in. That we can be on site and somebody goes, hey, I need a COM port over here. And they only have to run a cable to the nearest switch, and we can then say, actually, you become a COM network. So I've got a few more things on it, but I think I would be rushing through. But I'll get to, we'll come back to some of this next time. So the thing that Dom talked about is the little shiny stickers that we stick on things to say what the hell's going on. This sticker I've got here is an example of a show I've just done. So it's matching the sockets on the switch. This isn't quite the same switch, but you've got 6x2 pictures. And I've written one U show net, so our two QLab machines. The first two ports would be on VLAN 1, top left. We'll come back to that another time. And you can see the COM nets, where those bottom ports, we've got the helix in that panel. And that's the kind of stickers we leave. But I'm rushing this bit to get done, so I'll pick it up next time. So I'll pause there to give time for anyone to ask anything on what we've talked here, just before we add any new ideas, which we can add next time. I've droned on long enough.
Right.
Anyone got anything? Phoebe?
Hello. That the colours that you're using there, is that universal across all GOS? Because it would be really handy if...
I doubt it. I'm a nerd and there resistor color codes.
No.
Me. Maybe it's something we should talk about. I think the trouble is, Phoebes, at this level, each show is slightly different. We have a couple of networks that are the same on every show, and then there's quite a lot of variance, and it's quite hard to standardize.
Okay, even if like the first.
Jump in as to what, as production engineers, what we try to standardize this to would be when we're doing prep, what the most prevalent Cat5 cables available to us.
Yes, so at Stay Sound Services, because they have great patch color, huge variety of patch colors that are not by length, they are just a huge variety of colors of patch cable. What Andy means is you'll use red cables for all of one network. So anywhere you're running ShowNet, say, if you've got a lot of red patch in that warehouse, Andy will say, well, red is going to be our ShowNet on this show.
Okay,
Now,
great.
unfortunately, Andy, you might correct me, or Dom, but certainly in a couple of the US shops, the colours of the Cat5 patch are actually to do with length and not at all to do with...
Yeah, not over here. They just sometimes there's a glut of some and loads of the other. So it's it's whatever's available, and you just try and standardise it across. Well, you do. So you have ShowNet as one colour and then do RadioNet as another. And I hope it's pretty obvious because what they're plugged into, and it's kind of they're usually grouped together pretty much as well.
I think it brings up a valid point, Phoebe. It's probably more important to look at the sticker and then see what the colour of the cable is and see if they make sense. Because depending on the shop we build from, they may not make sense. And the reason I've chosen to add colours on these labels is to try and help it be more identifiable with the same network across different switches.
Colours definitely helps from a quick interpretation point of view. I mean, I can quickly glance at this sticker and understand what's going on. So I think colours is definitely a good thing. If we can standardise colours, then great, but it sounds like it probably isn't practical to do.
Is that sort of answer, Phoebe? It's hard to make a standard, I think is the answer. But as long as...
Yeah, no, it makes sense. It makes sense that the colour that you're using on the label might match the same colour as the patch cable.
We try to if we can.
Okay.
But I think the important thing to take away is just the concept that not every socket's the same and that what this information is about. Because then you can work it out from looking at it.
Dan Bailey, do you want to ask your question?
Uh-oh, this could be hard. What's your question, Dan? Has he bailed?
Sorry, my space isn't working in front of me for some reason. Russ, do the switches build an intelligent MAC address table so they can then intelligently route packets around the network?
That's how it works.
Cool.
Yeah, so if they've come across the MAC address since they've been on, they already know which port to send it to. If they don't, then they actually do a broadcast message to say, hello, where are you? And then learn where it comes back from. And then once they've learned it, they do. It's also, your computer does the same thing when it's harvesting MAC addresses versus IP addresses.
Cool. Thank you.
Yeah, absolutely. I'm shocked.
Russ, could you jump, Joe?
Okay.
Jump back to one of your last slides that just had all the trunks going to that one there with all the managed switches.
Yeah.
Could you just clarify something for me here? So, in your example you've got all of the trunks going to one switch in the patch room. Would I be correct in saying that that isn't actually necessary? And if, for instance, your front of house rack couldn't get to the patch room and instead you sent that to the amp room,
yep.
If everything's trunked and tagged the same, that would be fine and shouldn't make a difference?
Absolutely. And the slides I didn't get onto, which we'll start off with next week, is I recommend that you configure all the switches to know about all the VLANs in one part of prep, which is actually quite easy to do because you make one config file and then duplicate it to every switch before you customize it. But we'll deal with that next week. But by doing that, it means anytime you want to change the configuration, every switch already knows about everything. So you haven't got to sit and say, oh, God, I didn't tell this switch about this VLAN. So I actually like to set it up that it's completely universal. But the one thing to remember, which I haven't actually mentioned yet, on Ethernet networks, there's actually a limit to the number of devices in a chain before you get timing problems, and that's 7. So you should not have more than 6 switches between any 2 devices on your local area networks. So yes, it doesn't matter. We could route the trunking from any port, but we actually have to think about that, because we all don't think about the fact that in the back of a D20, it's actually effectively a 3-port switch. Each D20 is actually a 3-port switch. You've got the 2 sockets on the back panel, and then you've actually got the computer inside the D20. And actually that's a switch. So when we daisy chain networking through D20s, each one of those is a switch. And technically, there's meant to be a limit on 7 in a row, sorry. But as Andy, Dom, and me and others will attest, you can break that. But in some circumstances, it will cause the packets to get lost. So we don't have to worry too much with the sort of topology we tend to do. But it is one little thing to keep in mind when you do decide what flows to where. Also, the other thing to think about what flows to where is, of course, a trunk is a bottleneck point. I've got slides on this next week. But you should think about where the bottlenecks are and make sure you have bandwidth in certain cases. But we'll look at that in detail next week.
Great.
Trunking can go anywhere. Anybody else? That's pretty good if people have mostly understood.
Russ, I'm sure you're going to it next week, but what happens about redundancy?
As in, well,
as in, you lose a switch. Effectively, you've lost.
The thing is, if you think about it from
he's on a training course in the background. We're both on the same table. Apologies.
I don't know where that's coming from. Say I'm trying to think how to explain what I'm saying. The trouble with redundancy is, ignoring Dante for a second, that is geared up to be able to have a redundant path. Any one switch failing, all the devices to that switch, even if you design a clever trunking system, which again, there's topics to come on to, any loss of one switch, all the devices connected to that switch will fail. So it's, at what point do we stop thinking about redundancy? And truthfully, any one switch failing, the devices connected to that switch will lose their data. Now, on our shows, I used to say, oh, it was only Dante networks that truly mattered in the middle of a show. But to be honest with you, the amount of OSC we're now doing with trackers and all of that, now suddenly control nets are getting important. Radio mic monitoring is now a Dante network.
Well, I'd say pretty important.
Say again?
Comms as well.
Yeah, sure, Christ, yeah, sorry, comms as well. So I think, truthfully, you just have to have a spare switch set up with a generic set of ports that you can. What I've tried to do is, when I leave a spare switch on site, again, I'll come on to it, but when I leave a spare switch on site, I preset it with 4 trunks and a block of one major network, control network, show network, some Dantes. And then truthfully, any switch you replace, you can make a choice. It's not quite the right configuration of networks that you want. You just bin the thing you don't care about at that location to get you through the night. And I think that's sort of where I'm at with it. So this is sort of like 3 of the 4 that I've got planned. And this week's going to get quite specific to actually routing around inside a switch and finding settings and things like that. Now, for most people, that's something you'll never ever need to do, other than the very first steps of, as we talked about last week, with replacing switches. You need to be able to log into them and set their IP address and load the configuration. That's about as far as most people who are on this call are going to need to do. But I wanted to go a tiny bit further this week, because there's such a variety of people here who are interested in different angles of it. So this week I will go into that. But if you're thinking to yourself, why on earth do I need to know this? It's probably because you don't. And also, I've tried to put as much into the slides as possible as pictorial reminders, if you ever want to look at them in the future. So, and then next week, the plan is to go on to some more things, actually like digital audio over networking, specifically Dante and some comm stuff. So that's sort of the rough plan. Hopefully you can all see a PowerPoint slide looking at the default IP thing that we finished, well, didn't quite finish on last week. I noticed, sadly, Chris Lambrex is not here, but Chris actually asked a very good question at the end of last session, and I don't think I answered it particularly well, to be honest, and have thought about it since. So just sort of recapping for a few minutes. So last week we talked about how do you find the IP of a device if you don't know it, and the best way is honestly resetting it and putting it to its default. And then we talked about what you would need to set your computer to be able to talk to it, an address within its same subnet. So on this slide, we would have set our IP address to, somebody tell me what we might have chosen to go with this to make it so we can talk to the switch. We did it last week. Anybody? Be great.
192.168.0.5.
Correct. Anything like that. And the same subnet. And then so I chose 53. We could web browse into it and we could talk to the switch. Now, Chris, the reason I went back to that is Chris Lambrex said, well, hold on. Why don't we just set our subnet to something that, so if we don't know what the address of the device is that we're trying to talk to, so I've printed on here that it's 3.201, but say we didn't know that, and say we didn't want to reset it. Chris Lambrex's question, which I didn't completely understand at the time, was why don't we just set our computer to a subnet that includes more IP addresses so that the search tool can scan a bigger range of IP addresses and hopefully find it. And I kind of pushed this away and said, this won't work. And it mostly won't work. But I thought I'd explain why, because some people asked afterwards why. So if we wanted to include more addresses, if we set our subnet to 255.255.0.0, then it means our computer could search all the IP addresses beginning with 192.168. So we could actually scan a lot more addresses. So if we chose an address 1.1 and a subnet mask of 255.255.0.0, then a discovery program on our computer, in theory, could search the network for any IP addresses with 1.2 all the way up to 254.254, which would cover the switch or the device we're looking to find in this case. So this would work. The message from our computer to the switch would make it to the switch, and the switch would receive this message and get our IP address of where to reply. So far, it looks like it's a good idea. So, but the problem is, the switch has a subnet of 255.255.255.0. That is telling it that our message, which it believes has come from 1.1, is outside of its local network. And when any device is outside the local network, you forward it to the router or the gateway address so it can go between networks. So the router would try and reply via whatever it was set as its gateway address. And if nothing's been configured as a gateway or router, which is normal on our networks, we don't tend to link our networks between each other, the message doesn't go anywhere. So yes, our computer from our discovery program would send a message to the switch and the switch would receive it, but the switch would be unable to reply because it doesn't think that our computer is on the same network as it, and it doesn't know about any routing devices. So that's why Chris's idea doesn't work. If I explain that okay enough, maybe I've dived in too deep too early.
So it's a harsh start, but yes, you've explained it well.
But it's just to tie up a link, because I don't think I did it justice last week. For those that want to be really picky, there are the odd occasion where it would actually work, but they are not the normal. Cool. So that was that. I've updated the slides in the Dropbox with that included. So back to the favorite subject of VLANs and these pictures we got to last week. Now, I think checking in with people after last week's call, I think most people were comfortable with these concepts we got through and talked to, and the idea of why VLANs work and what they do. And we kind of got to this list of how on our shows we might have this number of different VLANs across the network. And then we moved on and we talked about the concept of trunking VLANs. So connections between switches can carry all VLANs, and the concept of tagging and untagging. So this is where in our pictures, we've done it with colors. The message gets colored as it goes into a port, and it's then associated with that blue network or a particular VLAN, and will only come back out of or look for a device on any other net ports set to that same VLAN. I think everyone was okay with that last week. Yeah, great. So that was sort of where we stopped. And so this was a picture of how the ports are set up on a particular switch on Diana, and with the names of the devices. So we can see the two QLab computers are connected to the ShowNet, VLAN 1 in this case. U stands for untagged. So it means at that point the messages have no tagging. The switch removes the tagging as it comes out the switch, which it has to do because most devices do not understand tagging. System 1 and System 2 are slightly special. We'll come back to those. We can see the console, a ECX port spelt wrongly. And we can also see that we had a KVM port on here set up. So on our 5th VLAN, so we could do a KVM link between front of houses. And we have some ports set to the COM VLAN so that we could do our Helix panel, HelixNet panel. And then on the left, we actually had some Dante secondary ports set up, connected to the ex-Dante switches at front house, switching QLab and Soundscape. And then on the right are the trunk ports that go down, in this particular case, actually went to the side of the stage and connected this switch with all of the VLANs, 1 through 10, to other parts of the network. So from what I sort of thought I'd do from here is actually look at how some of this stuff is configured within the switch. As I said at the start, some people may never need to go down this route, but at the beginning, I'll look at the filing and the sharing. There's 2 main ways to configure most modern switches. One is via a serial link, and one is by its built-in web server. The advantage of the serial link is you don't need to know anything about the switch to do it. So you don't need to know its IP address. You don't need to know how to log into it. It's a straightforward, but everything is done through command line. And anyone who isn't quite as nerdy as a few of us on here knows that command line is quite a tricky thing to type, and you have to be very specific with your words, and there's no graphics, it's all words. So for most of us, it's much easier to use their built-in web server, which gives us web pages to configure their settings. A word of warning, most of the time, and it really does depend on different firmwares of switches, Mozilla and Safari tend not to work that well with the switches. They tend to not be able to access all of the pages and don't display all the data. This tends to be. So if we're going to access a switch from our web browser, we need to know its IP address. We now know how we can do that. So we're going to say it's 1.250, which happens to be the address of the Cisco switch that Chris Mace sent me this week. When you go into a switch, it wants a username and password. Now, on a Cisco switch, it defaults to Cisco. So Cisco lowercase is its username and Cisco lowercase is its password. And if you've reset the switch, which is something I recommend you do before you start programming, as you never know what's inside the switch, that's what it will default to. Now, whilst we don't take security too seriously, we kind of don't want to make it dead easy for people to connect to things. So I tend to set the password to admin and then set the username to the admin and then set the password to the same VNC password that we use across the show. So in this example, all the switches on Diana have a username of admin and a password of but whatever happens, we should be good associates and leave this information inside the Excel document. I put this link in chat. Hopefully it's still there. Cisco have an online link, which I sent a few weeks ago, but we never got to, enabling you to virtually play with a switch. I thought this was a great resource, and it's helpful if you want to remember the menus, but it doesn't keep any settings you do. So if you go to a page and alter a parameter, as soon as you've altered that parameter, it resets immediately back to the defaults that the website uses. So you can't actually design a whole switch in it. It's not a true editor offline, unfortunately. So what I've tried to do is I'm going to try and do a bit of PowerPoint and then actually hop onto the switch that I've got downstairs and see if we can look at some of this together. These are the steps I believe, if you're starting from scratch in a shop, that we need to do. First of all, I believe in doing this to nearly all pieces of equipment. Reset it to the manufacturer defaults. There's always a reset item in the menu, or a hardware button. You hold a pencil or a sharp point against for 5 seconds and the device will reset. And the reason that I think that's particularly important, A, we then know what its IP address is so we can configure it. But B, it gets rid of any deep down settings inside the device that we may not think to go and look at. Oh, I've got chatting about that. And it means we know we start from a level playing field every time. First step we need to do is we need to give it its IP and subnet that we want to have for that switch, which we will have designed in our paperwork. In general, I place them, and I think most of us place them at the high end of our shownet, which is 192.168.1, and then we tend to use between 230 and 254 for our switch addresses. I certainly do. Matt and Andy, I'm not quite sure what you've been doing recently. Then I personally like to change the user account and delete the default account so that it's specific to us. Then I would configure so the switch knows about all the VLANs we intend to use. Then after that, I would set up other management features, which we'll discuss over the next 2 weeks. And then at that point, I save those settings to a file on my computer. And effectively that enables me to clone every switch to be the same as this point. And by doing that, all my VLAN configurations and all the other spanning tree and other information that we're going to get to, I can duplicate across all the switches very easily. So it's important, it's like a base state. It's important to get this right, I think, to get this bit right, and then use it to clone all the other switches from. And then you don't have to keep re-entering all that information, and it saves you making mistakes. Then, having made my file to clone from, I can finish configuring this switch to be exactly how I want it to be. So in the design, I would have worked out it's going in front of house rack, it needs some computers on shownet, it needs some COM, and I'll design which ports I want to be on which VLAN, and I'll make those assignments. And we have to decide for each port whether they're an access port, which, remembering from last week, an access port means it's a port that has been set so it can only have one VLAN, and that VLAN, the data coming out of it, is the tagging has been removed, so your computer doesn't have to worry about tagging, and going into it, it gets assigned with the tag of the network of the port you're in. And some ports will set to trunk, which is how we connect all the switches together, because the trunk carries all the VLANs. Then, having done this, and this is possibly one of the most important things on a Cisco switch, is they have 3 different configuration memories inside them, very unhelpfully, or maybe helpfully if you're working on big networks. The first is the current settings that are active. So having made all these changes, they will reside in the current settings. However, for professional networking reasons, they have a startup configuration, which every time the switch gets power cycled, it will load from that set of settings. So the most important thing when you finish configuring a modern switch, especially a Cisco switch, is you need to copy or save current settings into the startup settings, which it will use next time it powers up. So many people spend hours configuring their switches and then miss that step. And next time they turn them on, they're all back at manufacturer default, which is rather frustrating. And then you're ready to deploy. So have a quick look at some of these things here. So maybe this is the point that I dive into actually the real switch. New share. I think it's like this. Does this work?
Russell?
Hi.
Can I raise the point of firmware?
You can. Raise away.
That all the firmwares need to be the same on all the switches?
It is a very good idea to do it. And actually, it's starting to be really evident just how many generations of the Cisco firmware there are. So that is an excellent point. Again, if we're starting from scratch in the warehouse, ideally we should get the shop to give it to us with all the same firmwares in. A very good point. For the most part, it doesn't stop the communicator, but it is frustrating where the settings have moved in menu structures between firmware, which happens a lot.
It's certainly a lot easier when you're navigating around if everything looks the same, isn't it?
Definitely. Good call. Can people see the web browser? Has that worked? Yay.
Yes.
So this switch, I'm going to log in. Cisco. Hopefully. Please. Live demos are always scary. Excellent. So hopefully people can see where my mouse is, see this flashing save warning. I don't know if that comes through on the over Zoom. Up here, there's the word save with a red cross that's blinking. That's the first reminder that you haven't saved your settings into the startup configuration. And if you should be very conscious. I'll probably say it about another 5 times, given the number of times I've lost settings by missing that step. So there's various different menus down the left. And truthfully, certainly in the area I've been configuring switches, we don't use 2/3, if not more, of what the switch is capable of. But it does bring us some advantages, as we've already been talking about VLAN. So the first step I do is I go to administration, and then normally it's either under management interface or user accounts. As Ramon sort of implied, things move between firmwares. So on this particular case, under user accounts, and I would add another user. It will probably tell me that my password is not strong enough. But I personally believe if someone wants to hack our show, they have to directly plug into it, and also what are they going to achieve? We're not protecting bank details or anything, and we want something that people can remember, not have to go to a password store to dig out a 20-character string of nonsense. That's just my view. What I would do after this is I would have to log out, and then I would come back in. I'd be able to delete the Cisco default. So now we've done that step. Now I'd log into the switch using admin. This particular firmware version allows you to delete accounts without logging out, but previous firmware versions haven't. The next step I would do would be to set its IP address. So it's this thing called management interface. And if you think about it, inside the switch, it's a switch, but it's also got a small computer built in that acts as this web server that's providing these pages. And that has to have an address. We have to have a way of talking to it. And as far as the switch is concerned, this is how you manage the switch, how you control it. So that's why it's called management interface. IP version 4 is pretty much all we've talked about. I did briefly mention there was a new format of IP address that has a much longer address, but it's still not that common in a lot of the world. So we're going to ignore it still for now. We don't need to worry about it. So at this point, we'd want to make sure our address was static. Otherwise, every time the switch booted, it would have a different address, which would mean we wouldn't know how to connect to it. We talked about that, about not using DHCP and using this. So in our case, we designed that we're going to have this switch as 1.250, and that's its subnet mask. And there's no gateway because we don't have any devices. Now, this is something to remember. The second I click apply, if it's actually changing its address, then that switch will move immediately to its new address. Now, under some firmware, it will automatically change my web browser to that address. And other firmware, it'll appear like the switch has just disappeared. So you'll just have to know to go to the new address you've typed. If you're moving it from a different subnet, because say the switch's default is 0.254, then once you hit this apply, you have to then change your computer's network settings again to be within the subnet that the switch has moved to, and then you can reconnect to the switch. Make sense for people? Super. I'm not having to cheat and look at my list this week. So the next most important job is to disable a couple of things. And the first one is to be anti-green, unfortunately. So in port management, on most switches, there's green settings, so energy saving settings. Now, in theory, these are, we should be adopting everything green or saving power. The trouble with the what's called 802. This EEE, energy efficient Ethernet, is that any precision time protocols do not work reliably across one of those, a switch with those settings. And that sort of makes sense, because the idea of an energy efficient Ethernet is that it slows down data rate when it doesn't need to be at high speed. Things don't get delivered quite as timely. It does them in bursts rather than continuously being switched on. We're talking very fast still. But, so for the average user in an office, it would be absolutely fine to have that setting. But if we briefly touch on Dante, where we're sending clocking and sample data across the network, that has to be precise, down to 1/10 of a millisecond or better. At which point we cannot have a switch that's adding latency because it's got energy efficiency turned on. So if we're pretty much on all of our shows, we're doing Dante, so we would want to make sure that energy detect is turned off, short reach, I don't even know what that does, but that needs to be off, and that we turn off EEE. That's incredibly important. We can make our LEDs on the front of our unit be more energy efficient, that's okay. But that's a very, very important step on a managed switch, especially on a Cisco when you start flat, because they enable all of these savings. I'm sure other people are going to remind me of things I forget as we go through this. So the next step is to teach the switch about the VLANs we want to use. So there's a whole area called VLAN management, and then VLAN settings. Now there's already a VLAN sitting there, VLAN 1. And that's because by default, the switch needs a VLAN to work. And every switch would be set the same, so therefore we wouldn't know a difference. And again, our management server inside the switch is only connected to one VLAN. Now, those of us that have done this before will know what will happen later on when we get to port assignment. I'll come back to that point. But the first thing to do is to teach our switch about all of our VLANs. So it's a very straightforward process. I'm going to use a VLAN ID between 2 and 4904. I'm going to give it a name if it's easier. And we'll apply that. And then we'll add another one. So far, this should hopefully not feel very scary to people. And we'll put that in there, makes Gareth happy. So now the switch knows that it can deal with any of these VLANs. So if any of those VLANs arrive on any of its ports, depending how we configure the next few steps, it will handle those VLANs and know what to do with them. It knows they exist. It knows to expect them. And my belief is that if on a show you know that that's what you need where we've got to, I tend to always add a few more at this stage. And my logic
Hey, Raz, I don't think we're seeing any of the pop-up windows that you're working in.
Oh, that's irritating. Hold on.
It's just a refresh rate. If you work at a less Rust speed, it should work.
Oh, really? Maybe I actually need to share the whole desktop. Hold on.
Peplo to do it instead.
There you go. That's worked.
Oh, sorry. Well, thanks, Scott, for bringing that up. Wow, everybody else didn't speak earlier. So very simple down the bottom. We've got an add button. And then we have to choose a VLAN ID, and then we can set a name. So as I was just saying, I tend to set up, at this stage, more VLANs than I think I'm going to use. Because my idea is I'm going to use these same settings in all of my switches. And I'm going to set my trunks up between the switches to send all VLANs that the switches know about between them. What that means is if suddenly halfway through the load-in, or indeed in tech, or indeed in previews, we go, oh, damn, we really need to get some other data from A to B across our building. All we have to do is change a port on switch at each end to be on a different VLAN on one of our spare VLANs, and the data will just get across our network. We don't have to go into each switch on the way between the 2 points and configure the VLAN, configure it in the trunk. So I always recommend adding more VLANs than you need. So for me, I feel 1 to 10 and maybe a couple more. Everyone okay? So far, so simple, right? Not that scary a subject. At this point, having done that, I would set up some other features. And that would be spanning tree and multicast features. Now, we're going to just skip those for a moment. We'll come back to those a little later. Multicast we'll probably do next week, but spanning tree we'll hopefully do a bit later.
Russ,
Yes, sir.
would you just say one thing I always do is disable smart port, because I've had issues before where the ports changed type on you. So
Absolutely. You would. So Matt's absolutely right. We should be disabling auto smart port. And that's all you need to do. Do that. Smart port is where it is designed. I only know the basics of this. It's where it's designed to be in an office and you need several high-speed phone line, voice VLANs and video VLANs across your network. And the ports can detect when you change in your office what's plugged in the end and auto-select VLANs. So office people don't have to reconfigure their switches. They can just plug a phone suddenly into the end of the network socket. The switch will configure it onto the right VLAN. So we definitely want that disabled. Thanks, Matt. Yes. And the other thing we would do at this point, but again, we'll cover it in Dante, is QoS settings. But we'll just leave that for a moment. So assuming this is our base thing, now this is where we're going to look at filing and saving. So in administration, in file management, there's various different settings. Updating firmware is here. I personally think that's the job of the shop, but Ramon is absolutely right. We should make sure our switches all arrive on the same firmware.
Having seen Orbital have to try and update firmware when Ramon asked them to, it took Rich Carter about 6 hours to update the firmware on an SG300. To give you an idea of how much of a difficult process it is.
Yeah, I've done it a couple of times. I think it's easier just to let the shop do it. And truthfully, I personally don't think with all the modern releases that are out there, it matters too much which version we're on, as long as they're the same.
Maybe it's just a case of asking the shop to make, maybe it's a case of making sure the shop does it rather than doing it itself. It's something to be aware of and just making sure that we get switches with the latest firmware on them.
But from my point of view, what's more important than specific firmware in the switch is that you have all the same switches, like having a few SG300s, 28s and a few 36s or something, or a couple of 350Xs or something, because you cannot load the same set, so you can't load into a spare switch if it's not an identical switch.
I think it's imperative that we basically have the same model of switch across the gig.
Is there not a thing about needing a different type of switch at front of house though, because it's quieter than the standard one?
Non-PoE.
Does that affect firmware?
I have loaded on an SG350 PoE to a non-SG350 PoE, non-PoE. It will load the files.
Because I think the default spec says something different for the front of house position.
Just says no PoE.
Okay.
It does vary. I mean, I tend to, when I scan a spec, I tend to try and fix the switches to be of the same type everywhere on the spec, because there are a few copy and paste differences throughout.
Yeah, I mean, it's more of a Gareth when you're doing substitutions, you know, that, and they say to switches to higher shop standard. That's the point that I think we need to say.
Andy, it's very right. It also means you can stock less spares on site, and the config files will load easily between them. It's a very good point. Anything else, Andy?
No, carry on. Sorry.
No, good. It's all useful.
Aren't SSS's PoE ones 250s and the rest of them 300s? I think that's
yeah, exactly that. Yeah, which is one of the issues.
Yeah, I don't think they do it. Yeah.
I think it's something to be I think it's just something to be mindful of. It's a good point. Cool. So in here is
hang on 2 seconds, Russ, just so that I can clarify this. So in our master spec, we ask for SG350 28 MPs as our main switch, and then we ask for the non-MP version for front of house. Does that still make sense? MP is the PoE version, right?
And it has 2 fiber slots, SFPs, which we're going to have to start using for data rate.
And does the 28 MP have fiber slots as well?
Yeah.
Okay. Cool. Thanks.
So this is where the important step happens, and this is where you copy between the running configuration into the startup configuration. Now, it does default to those options, as can be seen on that screen. So if I just click apply on that, it will say, don't do anything else while I'm doing this. Well, okay. Hopefully it will cope with Zoom. And that's the end of it. And hopefully those that could see the flashing save, that has now stopped. So now we've taken the settings that are currently in the switch, stored them in the place it looks for at startup, and it means next time the switch boots, it should load back to exactly where we were. So for making copies to other things, and indeed, this is now where you would load settings back if there was a problem you were replacing the switch, is what we're going to do next. And I have to just stop and think for a second, because this one is different. And this is the problem with the different firmware. Am I being blind? Where is it? So I just need to do backup. Backup configuration from running configuration. There we go. So download backup configuration log. There it is.
You have the option to encrypt it in case it's got like a load of passwords and stuff in it, but that's not relevant to us, right?
Which I don't tend to do, because I like to be able to read the file and manually edit them, but that's me. And there's only one password in it. And again, if people are hacking our Dropbox, it's all there in the Excel sheet anyway.
Makes sense.
So we want to transfer HTTP, that's using our web browser. We want to download it, and we want to download what's currently running. Sorry, we want to backup, sorry. What's currently running, and we'll do it in plain text. This will give us, hopefully, a file that we can save into Dropbox, which is where we got to. But at this point, we haven't fully configured this switch. This is just my base file. So I would save that to my desktop as base config for now. But whilst we've got to this point, assuming this is where those people that might need to know on site, this is probably a useful point. So we would continue to configure all of our switches. One of the steps I do when I'm on site and I'm finishing a show and doing the final paperwork in the last few previews is I make sure that I save the configuration out of every network switch on the network. And I will name that file with the IP address of the switch and a name that we've called it in its location. So jump rack primary, front of house primary, etc., etc. And they'll all live in the data folder in our Dropbox. The idea being that if a switch ever fails and you need to replace it, once you've managed to get it connected to a computer so that you can load a file into it, you just need to take the right file for that switch from our Dropbox, and you would come to this menu, and probably we'd be helping you, or the shop would be helping you with this. And at this point, we'd come into the same menu, and we'd go to download, and then we would choose the file, which would either be from our Dropbox, or you may have copied it to your desktop or other things, and I can't find what I just saved. Base config, open, and then we'd load that, apply that into our running config. I'm not going to do it in case something goes wrong when I lose contact with the switch. Then we would come back in. Oh, one thing to note at that point is it will change the IP address of the switch at that point to whatever the file says it should be. So at that point, you might have to look at the sticker that was on the old switch, and now we'd navigate to the new IP address. And we have to, at that point, not forget to save running into startup. Otherwise, as soon as you unplug it and move it to the rack, it will forget everything again. And in theory, that's as simple as it is to replace a switch. And that is still going to be quite hard when you're on site. But it's one of the ways we do it. Those steps make sense. They are in the slides.
Russ, can I just jump in for a sec?
Please.
The flash in save icon at the top, is that a shortcut to do what you just said?
It will take you to that menu, but it won't necessarily apply the right tick boxes.
Okay, cool. Thank you.
I think from some firmware version onwards, it does actually do it all. But I personally like to make sure of the steps, just because I don't do it as regularly as some, and in theory, it should shortcut you to this point. Okay, everyone okay to that point? Great. So we've got our template. So staying with the VLAN theme for a bit, this is the point where we now need to tell the switch what each port is doing. So we go back to VLAN management, and for the minute, we'll look at interface settings. So hopefully you can see, so the switch has got 28 ports, and 1 to 24 are currently set to access, and 25 to 28 are set to trunk. And all of them have a PVID of 1, and they admit all frames, and they have ingress filtering enabled. That's a lot of stuff. Now, a lot of these things is fair. We don't need to delve into the detail of a lot of this. We are actually fundamentally doing quite simple things in networking terms. So by having the modes of access and trunk, a lot of the settings are done for us. There is there's many modes, but there's another mode called general, which takes a lot more configuration. You have to do a lot more steps. So I'm pretty much only going to talk about access and trunk. So reminding you with access, it's a port that is associated with one VLAN only. And the data, when it goes into that port, gets tagged, gets sent around the network to where it needs to. And any data coming back out that port gets untagged so that it's like it was before and goes straight to our computers or desk or whatever we want. So we need to set whether things are trunk or access. So hopefully, if I click on that and then click edit, people can see a window come up. If I'm in the right screen now, great. And at the top here, we can choose these other different modes. As I say, there is one called general, which some other sound teams I have seen using, but it needs a lot more steps to be ticked and sorted. I personally don't think we need anything different than access or trunk, unless Andy or Matt or others correct me at this point.
Is there any advantage to having it?
But you can't get rid of it. Yes, if you're really into big boy networking, corporate world, all kinds of real details, a lot of stuff I don't understand, then I can see the point. But for what we do, I don't think we do need it, and it's much safer without it. Because it gives you way too many options. So I want to change these ports 23 and 24 into trunk ports. We've got a lot more places we want to send all of our VLANs. And it is just as simple as clicking trunk. But when we change to trunk, it gives us the option of choosing what it calls the administrative PVID. What does that really mean? What that means is a trunk port can carry many VLANs. For it to be able to tell which piece of, so lots of data traveling on that cable, for it to be able to tell which network each piece of data is aimed for, it gets tagged with a number, the VLAN number. Any message that has this tag on it when it gets to a trunk port is fine. It will just be sent to any devices it's meant to on the right network. But it is possible to send messages into a trunk port that are untagged, at which point it's the same as a normal access port. Which VLAN do I associate that data with? And what the PVID does is enable us to set which VLAN any untagged data is set to. Again, I tend to leave on the trunk ports VLAN 1, our control network VLAN, as untagged, and tag every other VLAN, which you have to do. And the reason for that is I can then treat that trunk port as a normal access port on VLAN 1 if I want to. So I can unplug it from the rest of the network and plug my laptop into it and do some tests if all the other ports are full. It's a bit subtle details. That sort of makes sense. Did I explain that all right? Looking across faces. Okay. So we'll change that. We'll apply that. And that's now changed down here to trunk. We'll do the same to 24. So at this stage, not too much has changed. We've just set whether a port's going to have one VLAN and directly talk to equipment, or if it's going to talk between switches. If I go to port VLAN membership, this now lists per port on the switch which VLAN they are associated with. There's two columns for administrative and operational. Let's not worry for a second about the difference. But it's telling us that every one of these ports, even the trunk ones, are only associated with VLAN 1 because they only have a 1 there. And that all the data coming out of those ports will be untagged. That's what the U means. And the P means any data going into that port will become tagged with the 1. Yeah, pretty straightforward. So let's look at setting our trunks to carry all of the VLAN. There's, as so many things with mixing desks and everything nowadays, there's more than one way to do this. But this is the simplest menu, but slightly slower, but it's a bit clearer. So from our port VLAN membership, we're going to go onto our port 23, and we'll click on Join VLAN. So it's already saying that there's some helpful reminders what the different letters mean here. Already telling us that VLAN 1 is on that port. It's untagged, means it can talk directly to equipment, and any data going in will get tagged with VLAN 1 across the network. On the left, it has a list of all the VLANs it knows about that we configured earlier. Now, unless there's a really good reason not to, on my trunk ports between switches, set it so that every VLAN that I've defined goes between the switches, which includes the ones I know I want to use and some spare ones. So this means I can add things later on. And all the things I've just added were added as tagged because they have to be, otherwise it doesn't know which one they're for. If I remove those and try to add these things as untagged, it won't let me because it has to be tagged. Otherwise, how does it know what they're for? So this gives us a very easy way to add everything. And then down here, you can now see, hopefully, the list of all the VLAN numbers that now will work through that trunk port if you need to travel between that switch on that line. Yeah? And then we would do that for all of my trunk ports. I'll stop there because I get bored. So now we've set our trunk ports up. They will be able to communicate between different switches. I can connect one trunk port on this switch to another trunk port on another switch. And if something needed to, any one of our networks can communicate between those two places. So now we need to set our other ports up to be for individual devices. So one is our control network. So QLab computers tend to sit on one, console would be on one, etc., etc. So most of these, we might, if we were looking at our front of house switch, most of these we might want to leave on VLAN 1 only. But we're probably going to want a couple of COM ports. So for me, I've set COM to be up on 4. So gone into here, it's an access, so it can only be a member of one VLAN. So if I try to apply this, depending on the firmware, it either won't let me and give me a nice helpful warning so I can only have one VLAN, or on a later firmware, it actually just swaps them. So it would have removed one and assigned 4. So we have to do it manually. We assign 4. Now, if this was actually connected on our network at that point, that port has immediately changed to being on a different network. Instantaneously would now be on our comm network. Now, probably for the front of the house, I'd want to set up a couple more of those. Oh, remove first. Etc., etc. So it's actually really that simple to set up what each port is doing. And if you think about it in production time, if someone or one of the production engineers, we suddenly need another COM port on a particular switch, we've got spare sockets on the switch, but they're currently on VLAN 1, and we want to run another COM port, all we have to do is log in and just change that setting here, and immediately it could become for COM or something else. Okay? Everyone okay there? Any questions? Anything I've missed?
Sort of makes sense.
Yeah? So if we were finished at that point, our lovely save is flashing. Who spoke?
Sorry, it's Josh.
Hi, Josh.
Do we want to talk about what computers getting multiple VLANs?
Coming up.
Okay, never mind. Sorry.
No, good. I know why you're there. I'm trying. Hopefully, I've got a good enough order to hold all of us together. I hope. So we got save up here, and see if what Aidan says. So Aidan, this one didn't do it automatically fully. It just brought me to the menu, and at which point I could save my running into my startup, which I will do. Risk again, and that should be all good. So let's just have a quick look at what we've done. Can everyone see PowerPoint again? Did that just work? How exciting.
Yeah, it's working.
So these slides I'm going to go through fairly quickly now because it's just boringly repeating what I just did. But it's a reference you can look at later on. And then with that web link as well, if any of you want to have a look at it yourselves, you can. So we've set the IP address. We've given it a new user and deleted the default one. We turned off the green stuff. What else did we do? Smart port we turned off. Matt, I'll add a slide for that. I think that was an excellent point to remember. This was a tab I didn't talk about within the switch. In port management, port settings, there's an overview of all the ports. And actually, if we were on a long-running show and we were keen, we could actually put descriptions into each of these sockets to what they are. And then you could see if the link was on. Operational status up, down. Up means it can see a device, it's connected to something. Down means it's not. It's a way of fault finding at some level if you need to. That's probably for some of us and others. Then we defined all of our VLANs, giving them some names that help. That's a list of many, quite similar to the dialer list almost. Important step of saving, running to startup. All those steps are listed here. Here's some examples of different switch configurations and the different ports and networks we had in different locations. Then access and trunk mode. To be able to define these, we need to go through these steps. Define where access and trunk. So looking back at the menus we've just looked at. And then we have to define which VLANs are coming out of which ports. So that gets us to where we are. And if we think about our building and infrastructure of a show, now we can make any port be any network. We should just simply, as part of the design, within reason, put a managed network switch, at least one, we'll come to why more later, in each location, each main location. So we put one up in the amp room, or one of the remote amp rooms, one at front of house, one in the radio rack at least, one in the patch room, one in the band pit. And then any of those ports can be COM, radio net, control net. We can connect our devices as needed. So each of these are different trunk lines. And I think somebody asked the question last week of, does it matter which ports connect to which? How do we choose? We just choose. And there's kind of a philosophy that ports on the right of the switch are used for your trunks that go between switches. And the main reason that exists is on this particular picture of a switch I've got here, we have 24 ports that are copper ports, cable ports, and 2 ports on the very end that are fiber. So we can put in a higher speed module, like a 10 gigabits per second module. So they tend to be on the right of the switch. So in this example, on this switch top left, front house rack, I've set port 12. So it numbers, it varies switch to switch. This range of switch, the top row is numbered first, then the bottom row. So I've set port 12 to be a trunk, and that trunk is connecting that switch to the patch room. And I've set port 24 to be a trunk, and that's connecting that switch to the amp room, and so between our things. So now, any device on any VLAN we configure will be able to communicate anywhere across that network. That's our end goal. And this is now moving on to the subject Josh mentioned. Some network interface, so most computer devices, hardware devices, sound desks, all the other different equipment we use, don't like getting tagged messages into their ports. So they don't like having more than one VLAN, and they don't know how to interpret the tag number, and will not work. So that's why we keep saying we set most of our ports to being one VLAN only and untagged. So they look like normal data. They haven't got the encoded number on them that says I'm for this network. Now on Macs by default, and depending on which interface you have on your PCs, there is a way we can set up multiple VLANs into a computer. So why would we even want to do this? Well, if we think about maybe one of our system computers at front of house, we want it to be able to talk to the amplifiers, which is on our show net, and it needs to also, maybe we want to run WSM, so we need the radio network data, and we maybe want to be able to change comm settings in front of house. So now suddenly this one computer needs to be able to communicate to 3 different networks. And if we're adding Dante controller, it might need a 4th network.
And this is where traditionally we used to put loads of USB network dongles hanging off the back of the machine, isn't it?
Yeah, both because we used to use physically separate switches for each network at one stage, and then in our very first forays into managed switches, we carried on doing that. So for system 1 computer at front of house, we might have assigned 3 ports on the network switch at front of house, 1 with untagged VLAN 1 for control, 1 with network 3, radio network, and 1 with Dante, or COM, let's stick with COM. And we then connect 3 different network cables into that computer, which is rather wasteful and gets rid of this ease of connecting computers together. So in Mac, it has a way of making it that one physical network port can be treated as a trunk port, like a trunk port on a switch. And then you define sub-network interfaces, virtual network interfaces from this port, which with each tag. So you say this network device is using my Ethernet port, but it's only using messages from VLAN 1. Only data from VLAN 1 will come out of this. So it's like having 3 network adapters connected to your computer, but they're virtually all connected to one network adapter using different VLAN tags. So that's how come on, certainly I can think on most of the shows of people on here, at least the system computer and the radio computer only have 1 or 2 network cables going into them, but can actually access 3 or 4 networks. So in principle, if we're treating the network interface, network adapter on the computer as a trunk port, we just set the port on the switch to be in trunk mode and send all of the VLANs to that computer, or the ones we want, you can choose. And I, again, personally stick to leaving VLAN 1 untagged, which means I can always plug any device into that port and look at the management of the switch and leave the others tagged. So how do we actually do the computer end of this? Well, if you go into network settings on your Mac make this very easy to be fair to them, and Windows, it's only certain devices you can do it on. Mac, I think from is it Sierra onwards you could do this? Can't quite remember which one it came in with, but it came in a long time ago. So on the left, I've got my one network device on my Mac, which is a Thunderbolt Ethernet. And then down the bottom where the little cog is, you can click on Manage Virtual Interfaces. And then another window comes up with some pluses and minuses. And if you click on plus there, you can actually say, actually, I want to make a new VLAN. So you're not actually creating a VLAN on the network, you're enabling that Mac to understand that VLAN from a tag trunk. And I might say, well, it's RadioNet, and the tag number is 3. And that's going to be arriving on my interface, the physical connector, my Thunderbolt Ethernet. And I might do this for RadioNet and then ComNet and indeed the internet if we've managed to get that on our network. All 3 would have different VLAN tags. And what the Mac does is you have the one physical adapter at the top, which will remain any untagged data will come in and out of that. So if you've left VLAN 1, as I suggest, as untagged, that will still be associated with the network adapter, the physical real network adapter. So that would be our show net. Then I've now got 3 virtual network adapters that look like you've just plugged in USB Ethernet adapters that are looking for different tagged messages on the trunk coming in and then stripping the tag off them and making them to the software look like normal network connections. So in the case of this you just saw here, I've made a RadioNet, which is our tag 3 on our networks. I've made a virtual adapter for RadioNet with tag 3, and that will now look like that network interface. So it is exactly like I've plugged 4 physical network interfaces into my computer, 1 for each network, except I haven't. I've done it as a trunk, single trunk from the switch, and made it look like that for my computer. So that's why as I say, on system 1s or 2s on a lot of the shows and radio computers, you will only see 1 network cable going in the back of the computer. But if you go into network settings, you'll probably see 3 or 4 different network adapters. Does that make sense to people? Did I explain that okay? And it works because in the same way as it would work if we plug lots of USB adapters in, each of these individual networks has to have its own IP address and its own subnet, and all of them are in different subnets, so the computer knows they're on different networks. That's the important, but it's exactly the same as if we'd done it with physical adapters. We have to make sure all of our networks are in different subnets.
Russ, could I just ask a quick question?
Please.
A moment ago, you mentioned that sometimes we have computers where there's a physical connection and an adapter, but you said, oh, it might have 2 network cables going into it, but there might be 3 or 4 networks it's looking at. Are there still any applications where we need to do that, or could you just use this single connection, setting up VLANs internally, for everything now? Or are there still applications where we do need to?
For me, personally, there is only one case where I'm putting 2 adapters still on a computer, and that's because I believe Dante primary and secondary should never be on the same set of switches. So I have 2 physical ports connecting.
And if we ever do go into the world where we decide to break into the AVB network, as Avid 6 future versions are going to let us do, obviously that would be the same, Dante and AVB, and then everything else kept separate. But we're not really sure we want to do that yet.
But stuff next week, Joe, I draw that out a bit clearer. But yes, that's the only point, other than bandwidth, which is your other consideration. But I don't think there's for control point of view, I don't think there's a problem with bandwidth. So for me, I would do everything like this on a Mac, and then only for my second Dante network would I need a different adapter.
Pro Tools computers, we're still doing 2 at this point, right? 1 for AVBC, 1 for control if we need it.
Yeah, absolutely, Josh. Good point, actually. That's the other good case where we do still need 2 network adapters. When we're doing our Pro Tools record, AVB, well, depending on which way we're doing it this week, AVBC, which is the audio connection from the console to the computer has to have its own direct port, because otherwise it has to pass through an AVB compliant switch, which we mostly don't have. AVB requires much stricter timing than Dante, so it needs switches with a special mode.
On that subject, just a little technical support note type thing. We're still a little bit unclear as the last version of Avid software fixed 200 bugs, which I think is a wonderful demonstration of the fact that they are prepared to admit there were 200 bugs there that needed fixing. What we don't really know yet is whether or not it has fixed this occasional problem we have with the AVB network. So for the moment, certainly the safest way of running a Pro Tools computer seems to be AVBC to that Pro Tools computer, and then try and keep that Pro Tools computer generally off of any other network, because there is a possibility, as currently unfounded, but the problems that Joe and Matt and I had on Joseph seem to suggest that the show network got dumped onto the AVB network, and we had a Pro Tools computer that had the AVB network and the show network plugged into two different ports, which does theoretically mean that if something went wrong in that Pro Tools computer, you could somehow dump show network into the AVB port on the console and cause chaos as we those
this is sadly very much Avid's theory, and we're just doing it out of an abundance of safety.
We don't know
There's not a lot of technical grounds for that to be how it happened, unfortunately.
No, there's not a lot. It's generally often the case with Avid, where there's not a lot of technical grounds to back up any of their theories as to what goes wrong with the desk. But I think keeping the Pro Tools computer off the network and just connecting it to the console with the AVBC connection does do everything we need it to do, because I actually thought we needed the network connected in order to make VenueLink work. But actually, VenueLink works down the AVBC cable, so you don't actually need that machine on the network.
It was just for ease of dumping data, and as there's no good reason for that, you're right.
So for the minute, until somebody proves otherwise, Pro Tools computer is not on the main network.
Thanks, Joe. So does that all sort of make sense to here where we've got everyone? So that's how come we do that. I don't have a Luminex switch here, but I thought I'd have a look at how easy Luminex make what we've just looked at. Now, we sort of discussed last week why we don't use them, and it's more a case of cost and necessity than anything else. However, if we had endless money, they are an awful lot simpler to configure because they remove even more options, and they just give us the bare bones of what we need in the professional audio and video world.
Mike Thacker might be able to tell us exactly, but I think they're 4 times the cost of an equivalent Cisco switch, I think. And it is basically a fancy firmware and a posh box, I think.
Fundamentally, in the early ones, I don't know if they're still the same, inside the box was an ST300 board. But with different firmware running on top of them. But basically, it's the web interface. The different web interface was put on them that enabled them to behave with so many things automated for them. But I just thought we should touch on the Luminex switches, as some of us do use them and they are an awful lot simpler. But they have sadly decided to choose different names for the same thing that professional networking use, which I find personally frustrating as hell. Use the same terms. Anyway, so they do make it a lot simpler, but they have some limitations. Most of them, well, in fact, nearly all these limitations don't bother us at all. Within a Luminex switch network, each switch can only know about 20 VLANs maximum. The big Cisco switches can know about 4,095. I don't think we're ever going to need that number of networks in our little world, but 20 is adequate. I haven't yet got over 9 in use. Target for Gareth at some point, something new we've got to do. Same thing still applies under the hood. They still work exactly the same way. They just present the control interface in a very different manner. Each VLAN still needs a tag number, and they allow us to do nicer things in the GUI, like we can color each VLAN, give them a color, make them easier to pick up. Now, they don't call them VLANs, they call them groups. So they have groups 1 through 20. By default, and you can configure this, group 1 is associated with VLAN tag 1. Group 2 is 200, 3 is 300, 4 is 400, etc., etc. You can change that, but that is the defaults. So if we, without doing anything else, set ports to be on group 2, they would be using VLAN tag 200 as far as every other professional switch in the world would think. Very similar to a Cisco switch, you can choose for each port which group they belong to. And they also offer us a way to make a port into being a trunk, except they don't call them trunks, they call them ISLs, or inter-switch links. Arguably a more logical name. You use that port to connect switches together, and it will send all the VLANs through those.
I actually think most of these naming conventions make more sense to the layman.
I mean, that's why they did it.
Yeah.
This isn't the real GUI. This is their offline GUI. Because I don't have a Luminex switch. We're going to talk about a couple of things on here. So we have our 12-port switch. So one of the earlier Luminexes had very few ports, but the good thing about them was they were all Ethercon. So you didn't need to put panels in to convert from multi-cores and other things. The bad thing is that means you physically can get less connectors on the box. They do now make a 26-port one, and there's more versions with fiber ports, etc., etc. And you have this column called group, and currently they're all set to management. Now, again, they've named VLAN, their group 1 as management, and it's the port, it's the VLAN that their web browser exists on, how you can configure the switch. We'll come back to some of these other things in a second. So if you click on one of those, you can expand the list, and then per port, the very first option is to set that port to be an ISL port, so putting it into trunk mode, which we would use to link switches together, or do our trick of getting lots of VLANs into a computer in one cable. Both we would use for both of those. And then we have the different VLANs. If they were named, it wouldn't say group 2, it would say radio, tracker net, and 3 would say radio net, and 4 would say comnet. So it makes it a lot clearer what you're doing. It's a lot easier interface. Same thing with the management. It's on VLAN 1. So you have to be connected to a port on VLAN 1 to be able to talk to the switch. So that's just a brief look at Luminexes. I'll keep popping back to them periodically, but what had to be explained through 20 slides before is so much simpler. They do make it easier, but they're just a shitload more expensive. So the next area, I think that covers everything around that area, Josh and Andy, is to look at more bandwidth or redundancy connections between switches. So if we're on copper, we're currently limited to 100 meters, 1 gigabit per second. Now, as we're starting to realize on our shows, these trunks, certain occasions, are needing more data than 1 gigabit per second. And okay, we could use the fiber ports between switches, 10 gigabits per second, which I think we're going to have to start doing. And I think Andy and Matt have been doing, and various others on different shows. But if you want to make more bandwidth, you could think that maybe the easiest way to do that is just to add a second cable between the switch. So we do 2 links and we set all of them to be trunks. Surely that's a good way to work. Maybe that's a good idea. This unfortunately does not work without some settings in the switch. And if we think back right to the very beginning when we discussed how switches work, they learn how to find devices by learning which ports to find that device on. A switch cannot cope with a device sometimes appearing on one port and sometimes appearing on another port, because it would be random depending if it were data sharing between these ports, which port the switch would use to get data between them. So this computer, from the front of house switch perspective, the front of house rack switch, this computer connected to the amp room switch sometimes would arrive on its port 12 and sometimes would arrive on its port 24. Switches are, unless they have a rule, computers like rules, and it would lose data if you just did this. If you just blindly connect 2 cables between 2 switches, data gets lost. In fact, network flooding happens, all kinds of very bad things occur, and all the data effectively gets stopped eventually if you do this. yeah, I'm sure most of you have seen on our shows that we do this. We do find a way to connect two cables between switches. Now, on our touring shows, I kind of think of this more as redundancy than for bandwidth. Up until recently, I haven't worried about bandwidth because 1 gigabit per second has been absolutely fine. And the idea with the redundancy, if we've got our bundle or multi-core from front of house to the stage, and one of those Cat5s gets damaged as it's being pulled into the building, we plug 2 up each week doing the same link between the 2 switches. One of them should work. And it gives us a form of redundancy if a cable gets damaged. But we have to configure this. And in switch parlance, this is called link aggregating. So what we're telling the switch is, yes, we know it's 2 cables and it's using 2 ports, but for the switch inside itself, it needs to treat them as one single link. So we're going from a physical cable, 2 physical cables, to 1 link, and we'll start using the word link. So we're amalgamating 2 cables together as 1 link. And the switch will use this for 2 reasons. One is redundancy. So if one of those cables fails, all the data will go through the other one. But if normal working, if they're both connected and happy, it will share the data load that needs to flow between those 2 switches, between the 2 cables. So we have to teach the switch that they are a link aggregate. The 2 cables are to be treated as one. And in a Cisco, this is a few steps. So you'd have to assign the 2 ports to be in the same lag. So what do I mean by that? Well, we might do multiple links to multiple switches. Each of those have to exist as a different definition because it's individual links. So we're saying link between front of house and amp room is 1 lag, 1 link aggregate. If I was to do my front of house rack to the pit with 2 cables also, I'd define another link aggregate on 2 other ports. And then instead of setting each port to be a trunk.
This is something that we would want to be doing between all of our main managed switches.
Yes and no. It's a cheaty bandwidth thing, but to be honest with you, I think we should just be doing fiber from a bandwidth perspective. We're considering doing multiple links for bandwidth. I think we should be just doing fiber. Andy and others jump in if you disagree, but that's my opinion. And
fiber would be a loop because there's only 2 ports.
No. No, it would still be star. Well, you could do it loop, but it can still be star. I'll draw it out in a bit. You don't.
Right.
It could be an open loop. You don't have to join the ends back together.
Is Dan Mack on this Zoom?
Can't see him.
Hello, I'm here.
Oh, is it?
Yeah. So Dan, talk to us just briefly while we're on this subject about what you were saying about Don Bilkey discovering about how sometimes when we first turn R1 on, we don't get devices on the network, and what they discovered with DNB's protocol and link aggregate stuff. What was that again?
No, that was purely down to I think the discovery on that was that the network in the back of that is a 10100 adapter, I think, in the network switch in the back of a D20 or a D80. Therefore, it doesn't hand over to Cisco's quite very well.
The main thing in my reading, which I was going to get onto, is about disabling a couple of settings on link aggregate, Andy, that cause chaos.
Sweet. I look forward to that bit.
I'm sure you do. And I've actually got further information on mine, the DNB, that I've discovered anyway with DNB stuff, but we can get to that. So yeah, instead of setting in the 2, so we've got 2 ports part of our aggregate. So looking at the front of house rack, ports 12 and 24. We no longer set those 2 ports to be access or trunk and set which VLANs are on each of those ports. They're now, as soon as they hit the switch treats them as one entity. So now we have to set for the link, that particular link aggregate, whether that aggregate's to be access or trunk, and which VLANs that aggregate gets. And that's done in a slightly different place in the switch. And I'm wondering if I should hop back to the switch. Is it there? Yes. Has it switched? Oh, yeah, I changed it. Everyone see the switch? Am I back? Yeah, great. So, except I have no mouse. So in port management, there's a menu called link aggregation. And if we go to link management, this particular model of Cisco switch can have up to 8 different link aggregates, so 8 multiple pairs, 8 times multiple pairs of connections. And a link aggregate doesn't have to be just 2 cables. It could be 3, it could be 4, it could be 5. And there's different reasons for other people. For us, it makes no sense. The first thing is this thing at the top, load balance algorithm. And what that is about is when there's more than one cable and they're both working, how does it decide which messages go down which cable? How does it balance the load? And it will do that until it runs out of bandwidth on one cable. As soon as it runs out of bandwidth on one cable, it will start using the other cable regardless. But it can either decide the load which one to use by a little bit of maths on the MAC address of the messages, or it decides using IP and MAC. In our world, given our small range of IP addresses, I believe it's more efficient to use MAC address to do the load balance. So now we need to set up our lag to do what we want. So we'll select lag 1. And it's a very simple first step in here. We just need to decide which 2 ports are part of this lag. And 12 is the last socket on the top row. And 24 is the last socket on the bottom row in the example in our paper. Click apply. Port from your GI24 belongs to VLAN. Because they're not. So what it's telling me there is those ports are already partly set up in the VLAN and it doesn't know what to do with them because you no longer per port configuring what they're doing. So I just need to clear. This is where changing what we're doing got me through. This firmware version is very annoying. I've literally got to clear. Each of the settings back off to an access port to be able to join them together. Cool. Hopefully, go back into my lag menu. Should now be able to add 24, please. Yes. So we've defined on our switch that ports 12 and 24 are to be treated as one connection. Now it's currently telling me that the link is down and that these are standby members. And that's because both of them are disconnected at the moment. So they both could be part of that link, but they're not currently available. If I plug one cable in, it would jump to being in the active member column and the other one would still be on standby. So it could be part of the link if it was present. Now the thing that I've learned that you have to make sure is disabled is LACP, which is an intelligent way for switches to talk to each other to decide which cables to be used as part of a link aggregate or not. And it can be a process that takes 5 seconds at a time if the switches decide to change configuration, and therefore data is lost. And this is one of the things that came in a particular firmware version that I certainly was guilty of not noticing to turn off. So in LACP, is it in link management? Is it in here? Yeah. If I type the lag name in, it would get enabled. Some firmware versions enable it by default, and we must turn that off. So now, having made my joining of these 2 networks together, we need to say, oh, actually, we're going to use this as trunks. So we go back to our VLAN management, interface settings, Then up here, there's a little drop-down box, which currently says port, but actually I want to look at the interface settings for a lag. And then now I go in here, my lag 1 is already set to trunk because it's logical that multiple cables you would be treating as a trunk. It's already done that step for me. If I go to port VLAN membership, here's a little warning sign on this page. Under the lag column, you can see port 12 is a 1, 24 is a 1. As we've already seen, if these settings aren't set to be flat, then it moans. And so I can't configure these now. I can't even select them because they're part of a lag. This is good in the new firmware version. In older versions, it will still let you change things in here, even though it would do nothing at all, wouldn't change anything. So up the top, we change to lag again. And lag 1. Now we join the VLANs like we would have done elsewhere. So we'll keep our VLAN 1 untagged, select all the others as tagged, join them. They're now, that link is now configured, and that is done. So that's the differences with a lag in setting VLANs. These slides just walk you through that step, for those of you that want to look at it later. Now to look at how easy Luminex makes this. Is that cake nice, Mike?
Yeah, share the cake, Mike.
Oh, wants with cake. Luminex make it very easy in that it's just one tick box called R-Link-X. And if R-Link-X is ticked, that port can be part of a link aggregate, multiple connections between two switches. So if you don't have to do any configuration, you have to tell the switch they're joined, it works it all out for you. So if I connected port 1 and port 2 on this switch to 2 ports on another switch, and long as R-Link-X is turned on both ends, on both cables, it will just work. And that has made a link aggregate. As simple as that, which is rather nice. There's also, I think on most firmware versions, on the outside of the unit, a blue LED next to each port. And if the blue LED is lit, it's acting as a link aggregate. Does anything else sprung to mind, Dan and Andy, as you were on this subject?
Nope. Nope.
So here's now a slightly different configuration where we decided to do redundant links between different locations. I think this is something I used to do, and I'm starting to not do it anymore, but it's a way of slightly more bandwidth. And actually on Diana saved us on our MES front of house to the main racks by having that 2 gigabit per second bandwidth. Really should have been a fiber link, learning for future. Yeah, everyone okay with that? Something we haven't touched on, but thought I'd do a very quick touch on PoE, which is not Prince of Egypt, it's Power over Ethernet. And it's basically what we're all used to in phantom power on a microphone signal coming from the sound desk. Audio signal goes from the mic to the desk, but coming back from the desk is 48 volts, so that the microphone little preamp can work. And it's exactly the same with PoE. There's 8 wires in a normal gigabit, in a normal Cat5 cable, Cat6, Cat7, and paralleling those from a DC point of view, they apply 48 volts. There are different standards of PoE, but unless Andy speaks up and tells me I'm wrong, I think most versions nowadays are the same and they auto-configure. We don't have to worry too much. It's either on or off or protected from the switch. And there's an awful lot of devices that can be...
Yeah, the only one Steve Jones told me, just be aware that some pretty standard PoE devices don't supply enough current to do the D&B lasers. That's the only one that's worthwhile knowing.
Yeah, thank you. Many devices can power from PoE, and it makes it we don't have to run a wall or power supply or mains out to lots of places. We can just run the Cat5 data and that's it. And the network switch provides the power. Examples are HelixNet, their COM panels can run from PoE. R70s we discovered can run from PoE. Another one that on Starlight was a save was Dante Avio devices, which are these small Dante interfaces, can be powered from PoE. D&B laser sights on their grids, bumper bars can be powered from PoE on some switches. So it's very, very convenient. Now, in most, you can actually find PoE on both managed and unmanaged switches. On managed switches, you do have some configuration options. This is mostly involving power limiting and power priority. Some devices are much more thirsty on power than others. We don't think about it when we're plugging it into the mains because the wall wart's the right number of amps, but we've probably all come across wall warts that are half an amp, 1 amp, 2 amp DC. And the similar thing happens with, that's the amount of draw the current that each device needs. Same happens with PoE. A switch can only provide so much power, and they do have settings in them that they can limit the power to certain ports, or you can say, well, if you're running out of power, always power the devices on ports 1, 2, and 3, and 4, but don't worry about things on ports 7 and 8. I think we should never get into that world, and we should make sure that we have enough power, the right size PoE on each switch. I think that's pretty much it on PoE, but it's something to be aware of. And there's another reason why we tend to spec PoE switches almost universally, and I think most shops are now got them universally, is because so many devices can be done for it, especially COM. It makes production COM a lot simpler.
Is there any reason why you wouldn't want to use a PoE switch?
Other than, well, I personally think, my view is I think not, because unless there's you can lose data because the switch fails, you've lost data because the switch fails. It doesn't matter whether, you know what I mean? It's a central power supply to lots of things, but if the switch failed anyway, you still wouldn't be able to use those things.
Yeah.
So I personally don't see a reason not to.
And just for my own clarity, if you've got your managed switch and you come out of one of your VLAN ports on the managed switch and you go into an unmanaged switch, that is just like splitting that single thing. You don't have to do anything special.
It has to be well, unless if it's going on to end devices, it has to be untagged. You can't take a trunk port out of a managed switch into an unmanaged switch and then pass it straight onto devices.
Okay.
Now, you can do that, providing all the end devices connected to that unmanaged switch can handle trunk data. So, for example, we could do that between the front of house mix position and our tech table into an unmanaged switch, and then into each of our computers, and then have multiple virtual interfaces set up on our computers. That would work.
So an
unmanaged switch has no way of removing the tagging.
So that unmanaged switch we could just literally treat it like a split. Like it is just taking the same signal.
In essence. It can't change the structure or differentiate between the different VLANs.
But providing you just want to take effectively one cable and split it into 5 cables, you can put an unmanaged switch on the outputs on a socket of managed switch.
And in general, if you do that on an untagged port, you'll have no problem at all. You'll just split that one network. So an example of that might be, we might save the rental shop a lot of money by connecting all 20 radio receivers to an unmanaged switch in the back of the rack, and then one cable out of that unmanaged switch into a managed switch, one port set to being untagged radio network, and then now that data is available anywhere on the network, but I haven't wasted a managed switch between all the receivers.
Got you.
That's an example of where we can do it, have done it, do it. Cool. So now
I just thought one device that's a standard device we use, and discovered it on the last gig. It's I don't know why it's in big bold letters on the first page of the M1K2 manual. Do not use PoE switch.
Huh?
First page of the what, Andy?
M1K2.
Okay.
It must be they don't have the circuit on the front end that isolates the DC.
Why on earth would they be missing that on such a high-end bit of kit?
I don't know. Anyway, I thought I'd killed it, but turns out someone else had killed it.
So you told everyone.
So it wasn't marked next to the port on the device that you can't plug a PoE switch into it?
No, it's in bold in the manual there.
Yeah, but how many of... I mean,
that is a reason to turn PoE off on some ports on a manual switch.
Well, but I mean, the Cisco's auto detect, don't they? They don't actually provide voltage until the device
asks for it,
I believe.
Yeah, they put a different. There's an impedance put across some pins to tell it that I want these.
Yeah.
But that is a good reason. Some things I didn't think there were many things out there that couldn't cope with PoE, but that's a good one. That's an expensive bit of kit not to cope with PoE.
That's really surprising.
Yeah, totally. I mean, I only read the manual because it was broken.
I was going to ask why you did that. Cool. So on our topology and layout, there's one other layout that we have all come across but may not have thought about it, and that's a closed ring. And in actual fact, it's not done quite in the same way, but anyone who's used Digico, optical loops are closed network loops. Everything loops round. And same in the Avid. Up until recently, they only supported ring topology. And there are some things to making ring topology work. And both, I know Matt, myself, and Josh, trying to work it out with me, had problems with this on our recent shows. And it was all down to settings again, there's no surprise. So So you might think that a ring's a great idea, because if you lose any one link, any one connection, the data can go the other way. They're all just network switches. So you think it's a really good redundant option. And in actual fact, it is an enormously good redundant option if we are worried about cable redundancy, i.e. any single cable getting damaged or stopping working. But you have to configure it. So it takes a bit of configuration on your network to make this work reliably. So if we look at it as drawn like this, we might think this is a fantastic idea. So we have our network switches at front of house, in the substation, in the amp room, say, and we've done a ring of trunks around the building. And we would think that's great, because in theory, any one link failing, we would still get data. So if data might normally go from the front of house rack switch straight to the amp room switch to the amp, but if that cable failed, it could go via the substation to it. So on the surface, it looks a good idea, and you could absolutely make this topology work, but it's another set of things you've got to configure, and it's called spanning tree. So spanning tree is designed for exactly this. But as I mentioned earlier, and maybe I didn't say it very well, network switches don't like multiple routes to things without having rules of how to use them. They get confused. They get confused to know where the device is. Well, should I go this way or should I go the other way? They like solid rules. And in fact, when they don't have a rule, data ends up getting lost because they get indecisive and they start trying to search. They do all the ARP messages searching for devices, say, where are you? Because they think it's lost because it's changed port. So you end up with a huge amount of data loss, and you actually end up with broadcast messages ending up going round in an infinite loop. Because when a broadcast message arrives at a switch, its job is to send it to every other device on that VLAN. Well, that will go out of one side of a loop, and then that switch will forward it to the next switch, and then so on. So in this drawing, broadcast messages would endlessly go around and use up all your bandwidth. So the switch has to know that it shouldn't treat all of these links as active at one time. And that's exactly what spanning tree does. So spanning tree, through some rules, says, well, I can see that I can get to this D20 through two different routes. Or in actual fact, it actually says, I can get network 1 traffic, all the VLAN traffic between these switches through two different routes. And it decides which one is the better route, and then temporarily disables the other one. So in this particular situation, these switches may have said, well, we can all see each other, but I think the front of house to amp room to substage is the best route because most data is going front of house to the amp room. So we will temporarily disable one of the cables. Now the link lights, the lights that say there's a cable connected, stay on. This disabling happens under the hood. And if you go into the spanning tree menu of the switch, it will tell you it has disabled a particular link. And it does this for several reasons. And it's A, so there's always a known path to go, and B, it stops broadcast messages endlessly going around, because effectively this link is no longer working. So the way spanning tree works that out is it gives each link a cost. Like working out how to drive your car. Do I go this route or that route? Which is the harder route to go down? Which is more steps? Which is slower? And in our very simple example here, there's really nothing in either link, really. But in much more complicated networks that drive the whole computing world, there is huge amounts. So we don't have to worry about configuring these rules particularly well if we want to go down this road. We just have to enable spanning tree and make sure it has the right settings. That concept work for everybody? And the way this would work is if this link between front of the house rack and the amp room suddenly failed, it would immediately, spanning tree would do, well, not immediately, depending how you configure it, it would re-enable this dark link to be active again and data would continue. Yeah? So here's a drawing of a failure, and there it re-establishes the other link. But an important thing to say again, the lights do not go out on the switch. The link still looks like it's connected, even when it's been disabled inside. Again, more acronyms, and I'm really sorry. There was a version of this called STP, or Spanning Tree Protocol, which is old now and is very slow and is not very reactive to change. So it takes a good 10, 15 seconds to realize a link has failed before re-enabling another link. Not that helpful. It was superseded by a rapid spanning tree, which is the one we should use. Now, if you're getting into a really weird world, and I haven't drawn this up because I couldn't think of an easy way to do this, but I had to do it briefly on Diana and got into trouble. And I think, Matt, maybe you, I can't remember if it was multiple spanning tree or something else that got you. But if you have on not all your VLANs traveling down every link, and different VLANs have different routes between different switches, there are not many good reasons to do that in our world. If you disable the whole link, a particular VLAN may no longer have a path if they don't all travel the same way. So without going into too much detail, what multiple spanning tree does this per VLAN. So it decides which links to use without creating a circle per VLAN. But honestly, I should never have got into having to do that and will not do it again. And I can't remember what other things were, but that's just so people understand that setting does exist. And you only would need to use multiple spanning tree if you have VLANs not all going down the same trunks. So back into our wonderful menus in our switches. Spanning tree needs to be enabled on any device that could be part of a circle, any switch that could be part of a circle, if you're going to do this loop. In the way I think about it, I'm just going to set, if I'm going to have anywhere on my network a potential for a circle, or I'm doing it for redundancy, which we'll discuss next week, looking at the time, then I personally just want to enable it on every switch. They do just work it out themselves. And there's a few, depending on the firmware, so we go into spanning tree and there'll be this global tick box, turn spanning tree on. Well, yes, we'll do that. We want loopback guard on. I'm not going to go into what that does, but it is to do with the transition between a link being on or off. There's a brief moment there could be a loop in that event. We want to use rapid spanning tree because it's much, much quicker. This is how it talks to each other and decides which links to use. And the other stuff is how it works out which route is the more efficient. And to be honest with you, in our small networks, we just need to leave these as defaults. Simple as that. Having done that on every switch, it will just work. I could now do loops, redundant loops between switches, and it will disable links as necessary. Now, I only have one thing connected to the switch, so this page isn't very useful. But if we're using Rapid Spanning Tree, RSTP, if I go to that particular menu, it will show me per port whether they're enabled or disabled. Or this thing called route, which if they're route, they're in charge of discovering paths. So it's nominated the one port I've got active as trying to discover which other paths to go through. So if you have a suspected, if you've set this up wrong, which is quite hard to do if you stick to the defaults, or you've got this problem with multiple VLANs, this is the only place you can tell that the switch has decided to virtually disable a port. If you come in here, it would say port 6 would be disabled. You'd look at your plan and what's connected to port 6, and that might explain why you've got a problem. Unless you plan on doing anything in a loop or having redundant loops, turn Spanning Tree off because it uses bandwidth up to do these discoveries and all kinds of things. It's another complexion. If you have decided that it's important to have a redundant loop around all your trunks, then enable it, but you have to do it on every switch and set all of these settings to be the same on all the switches. And that is probably an excellent place to pause or deal with questions or look at anything that anyone wants to ask from we've covered over the last few weeks. Because the next bit is getting into digital audio over networks, slightly back towards what we all enjoy doing.
That was really good, Russ. I've got a headache, but it was really good.
This is the week that was going to be hard because it's into some of the nerdier network stuff. As I said at the beginning, most people don't know the details of this stuff, but just having a vague clue that it exists might help you one day.
Yeah, for sure.
Andy, anyone got any questions? Feel free. Anything we've talked about, any subjects over the last few weeks, very happy to try and answer. And if I can't answer this week, I'll come up with it for the next time.
Russ, maybe it's something I missed.
No?
Where you've got multiple VLANs going into a single device, a single computer.
Yep.
You talked about how to set that up on the computer. Did I miss how you set it up on the switch? Are you just plugging it into a trunk port?
You would set the port to be a trunk port and then assign all the VLANs that you wish to that port, or you could just do all of them. So you didn't miss it. I don't think I specifically did it. If I log back into here. So if I spin back many a slide, one with a picture. Man, there's some number of slides. There we go. So on start. I wanted to get to a pretty picture of what we've done, but I can't get to it. So yeah, you would just go, man, no CPU left. If we go to our interface settings, say we got our System 1 computer we want to attach to port 3, as you suggested, Rob.
Yeah.
We'd turn that into a trunk port. And then we'd go to port VLAN membership. And we go to port 3, which we can now see is in trunk. And I personally do choose which ones go to it rather than doing all. So it's already got ShowNet, which we want to leave untagged as my rule. We'll add radios and we'll add comms. Apply. And that's that. Right. Now we'd be able to set up virtual interfaces on that computer for tag 3 and tag 4 and leave the default one for untagged.
Magic.
That's pretty useful.
As I say, you can do it on PCs, but not on Windows default. You have to have certain drivers and stuff. I've either hurt everyone's minds too much or some of it's okay and clear.
I kind of wish I was back in Amsterdam now so I could try some of this stuff out.
You just break it. I can't. The one thing that is bad about a managed switch is if you do get settings wrong, you can lock yourself out of the switch very, very easily. So the scenario I didn't mention is, I mentioned it a few times, that the web server within the switch is associated with one VLAN. So normally the management VLAN, in our world, we would leave that on VLAN 1. So if I'm plugged into a port on that switch with my computer and I'm configuring the switch and that port is currently set to VLAN 1, no problem, it will work. If, as I'm configuring the switch, that port won't stay as VLAN 1, say I'm going to define it to turn into RadioNet or ComNet, the moment I do that in the web interface, I can no longer talk to the switch on that port. Because now the web interface and that port are on different VLANs. So it's another reason why I always leave trunk ports and everything else set up as untagged VLAN 1 management ports, so I can plug into those and always stay connected.
Hi, Russ.
Hey, Dan.
Did I see you setting up VLANs for both Dante primary and secondary on the same switch?
You did, and I was going to come into that next week. My philosophy is that I do one base state incredibly well, and then set ports to it. I don't do primary and secondary ever on the same switch. That's not true. I did it on a workshop. I don't normally ever do primary and secondary on the same switch, which we'll talk about next week. But I make sure that they have different VLAN numbers, so if anyone makes a mistake or connects things in a way incorrectly on site, it should be a bit safer. So I just define them in all the switches, but it might not necessarily be carrying any of that data. No access ports might ever be set to those VLANs.
Cool, understood.
But I will, well spotted, but hopefully when we talk through Dante next week, I can make that a bit clearer and why. But you're already a step ahead.
Awesome, thanks, Russ.
Cool. Hopefully something useful. As you say, most people, this is probably a bit further than they need to go, but it might help at some point. Everything's in the slides. Definitely for everyone knowing a little bit how to get a configuration into a switch, I would say is useful. We'll put the slides and the video up as per. I'll definitely aim. Next week, I'm aiming to do Dante and multicast control. I think that will take up most of the time. Andy, Matt, Josh, is there any other subjects you feel we should do for everyone? Or anyone else got a particular subject they want so I can prepare?
I think you've pretty much covered. I think by the time you get to the end of next week, you're going to have covered everything any of us are ever going to need to know about network switch.
There's no need to talk about port filtering necessarily now. We're sorry if the rule is that we're not going to have Pro Tools connected in two places.
I figure we should have a nerd session between some of us about some of the other little bits, but I was not planning on doing that for the group because it's A, something I don't think we need to get into, and B, it's starting to get really complicated.
I mean, port filtering is something that maybe we do need to touch on because, of course, there's things like wanting to filter the System 6000 reverb, for example, so that every 10 seconds. And also filtering the S6L. I mean, those are two, taking the S6L so it can only see the ports that it actually needs to see, i.e. really just VNC.
VNC and VenueLink.
Yeah, not even VenueLink though, because VenueLink works on USB-C. On AV.
Okay, well, okay, maybe we should look at ATLs then.
I mean, I would have thought, it depends whether you think what you've got left to do that you've got currently planned is a whole session. Because
I've only halfway written the Dante one, and I figured for most people having a walkthrough of how Dante works and how to configure that might be quite a lot of stuff.
Yeah, I would have said that that's quite important, but then I think there's maybe a smaller one that is about filtering, because I think filtering is actually quite important.
No problem. I can get one together on that. But yeah, the plan next week was to get a bit more back to audio, Dante, and things like that, and walk through some of that. Now, with some of your newer network knowledge, hopefully some of the ideas of Dante might be a bit simpler.
Cool.
And then after that, we were planning to hit S6L stuff, weren't we?
That's right. Ginge, are you going to make us up a certificate for everyone who finishes this?
Puts up with it, yeah.
Do you need me to backdate it to last week as well?
Well, I don't know. Maybe you could do stage 1, 2, 3, 4. Maybe we could just do, hey, I survived all the way to the end of the networking course. I don't know, something creative.
I'm putting money on Peplo not making it.
For you.
And genuinely, if people, once they've looked through the slide stuff, if people do have other further questions, they're more than welcome to drop us a mail. And if it's something I've not explained well, we can do it the following week.
And I should just quickly say thank you to Chris Mace at Orbital Sound for getting us this networking switch.
Yes.
Was quite handy. And Uber and whoever actually packed it in the warehouse. Yeah, Orbital did actually manage, in the middle of no one officially working, to send us a network switch for training purposes.
There are guys still actually there officially working. Mace is one of them.
It has been very helpful though, because
Mace is officially still working. Yeah, Mace and Bill, Chris Edlam, and a couple of others are still actually working.
Well, that's super useful for us because it meant that we could get a network switch for Russell to do live demos. So, thank you everybody at Orbital.
Oh, thank you all.
Nice one. Thank you everybody. And at the end of next week's session, we should probably judge the beard growing competition. Andy Yanaki, Russell, Nate, yours is coming on a bit. Joe, I mean, we all know Ramon's going to win.
I was going to say it's always going to be Ramon, isn't it?
Ramon's always going to win, but we should just see. We could do a little competition. Wally's got a good beard going on, but he's always had a good beard going on. So, all right, nice one, everybody. Thank you very much.
Thank you all.
Cheers. Take care, everyone.
Thank you, Russell.
Thank you, Russ.
Yeah.
Thank you.